So what do you guys find for slope A? Slope of line A. It should be a positive number, right? Because this line's going up from left to right. What do you get? 3/5. I'll agree. What do you guys find for B? You can just say it.
3/5.
3/5 again. Fantastic. What do you find for slope C? Interesting. Is this correct? That's correct, but it's still just wrong. Right? If you owe me $10 and you give me 1,000 pennies, that's correct.
But it's not.
But that's just plain old wrong. So that's -1. How about D? Which pairs of lines are parallel? A and B and C and D. What are the slopes of parallel lines? Same slope. Yep. We talked about that yesterday. I just wanted to reiterate that, get you to walk through that again and prove to yourself again. In any time we have a description, if we're ever writing the equation of a line and we're talking about a line parallel to a given line, all we care about is that slope. That slope is the same. That's what we say here. Parallel lines have the same slope. Okay? Let's look down here. Let's read the description. You guys read it silently while I read it aloud. Example 1. Write the equation of the line that passes through the given point and is parallel to the given line in slope-intercept form. Let's interpret what that means. Somebody tell me what that means. Reword that. Give me an understanding. Reword that. From your flow chart, we're finding the slope of the line given. The slope of the line given is what? What's the slope of this line? The slope of that line is 3. I'm going to write it like that. After we find that, we use that same slope, and watch how I write this. I'm saying then that tells us that the parallel slope is 3. Those two lines next to each other means the word parallel in math. Okay? So the fact that the original slope is 3 tells us that the parallel slope, the slope of the line parallel to that line, is 3, and that's what we want. Yes, it's the number 3, but we need to interpret that that is the same as the slope of the other line. Okay? So the components we use for this, we use the point and our new slope. And then your flow chart tells you to go into point slope form. Why? Well, we have a point and a slope, so why the heck not? So we're going to put it in point slope form. Recall, we have to memorize point slope form. Right? We have to be able to know what that is. I'm not going to tell you. Recall, we put the 3 in front of the parentheses. Recall, we put the X with the X. Recall, we put the Y with the Y, but it becomes plus. This is minus minus. So we get Y plus 4 equals 3, X minus 1. Go back to the wording of the problem. Have we stopped at the right spot? No. Should we keep going? The next part is we get it in slope-intercept form by distributing. Then we minus 4. Is that where we stop? That's where we end. We want it in slope-intercept form. We're done. Good job. We have a second one. Yes, minus a negative number is going to be plus. Y minus -4 will be plus 4. Is that what you were asking? Okay. Look at the next problem. Look at part B. What's different between B and A? It's in standard form. Great way to articulate it, too. It's the line that is parallel to the line we want. That equation is written in standard form. Can you read the slope from standard form? No. Slope is not 2. Slope is not 3, nor is it 6. Okay? we have to use this to find the slope. We create a new question because we can't read the slope. How do we get the slope of that line to the right?
You can't find a slope in it. Why is standard form a thing?
Why is standard form even a thing? We put things in standard form. It's a different representation of the same thing. Lots of times when we go beyond linear, okay, we write things in standard form by default. Okay, whereas now it almost feels like by default we write things in slope-intercepts form. Okay, specifically for lines, because graphing's easier. So in standard form for lines, it's important. There's standard form in any type of equation, but there's only slope-intercept form for lines. It's unique to line. So standard form is actually, well, the standard across the board. And slope-intercept form is just unique for lines. So it's getting used to standard form in terms of other types of problems you'll see later on in your math careers. I just said you had a math career. Yeah. Okay, so we got to deal with this. We got to use it. We got to work it. We got to get it in slope-intercept form so we can actually read the slope. Turn it into slope-intercept form now, kids. Do it. So the first thing we do to get it in standard form is we subtract 2x. Then we're going to divide by 3. Because standard form has y by itself, it solves for y. And the component of that equation that we use is just the fact that the slope is negative 2/3. And we use that to interpret what that means in terms of a parallel line slope. A parallel line slope is negative 2/3. Okay. And then we use that parallel line slope and the point to write the equation of the new line. Remember, we were writing the equation of a line parallel to the line given. In order to write the equation of the line that's parallel to that line, we needed the slope. We needed the slope of the line it's parallel to. We first had to solve it for y. We had to put it in slope-intercept form so that we could actually read the slope. Yes, sir. It could be positive or negative. In this case, it happens to be negative. So the slope in the new line, the one that's parallel to it, is also negative 2/3. And then we drop our x-coordinate with our x, which becomes plus, and our y-coordinate with our y, which stays minus. And then we rock it from there. Our goal was in slope-intercept form, so we got to keep cranking. Minus 4/3, right? Negative 2/3 times positive 2 is negative 4/3. And then we're going to add a 6, add 6. So then we're going to pull it off to the side, right? If we're doing it by hand, we're going to pull it off to the side, right down to work on it. When we add fractions, we need a common denominator because it doesn't make sense to talk about 4/3 and 6 ones. We would need to add negative 4/3 to how many thirds we would have to compare them. So that would be 18/3. And now we can compare those two, and it's easy to talk about it. Negative 4/3 plus 18/3. Negative 4 plus 18 is going to be 14. So it's going to be 14 total thirds. Yes, sir. I multiplied top and bottom of the fraction by 3 to get a common denominator so that they were essentially in terms of the same units. And there we go. Barbecue pork. All right, let's pull down to the next one. Your turn. Let's just do the second one, and then you guys can crank that on your homework. Where do we start? Where do we end? Think about the whole process on this. Read through the whole question. Understand and interpret the question prior to going after it. Okay? Understand what you're specifically asked to do, as if you're reading a story like Macbeth or a play. You have to be careful in how you read it. Same thing is true with this math. You need to be careful how you read it, because little changes can make a big difference. To find the slope, you solve it for y. That allows you to solve for the slope. You need to know why you're solving for the slope. Oop, that's a 2. So the slope of this one is negative 3 over 2, which means the parallel slope is going to be negative 3 over 2. And then we can put it in the point slope form. Yes. So then we put our slope in here, put our x with our x, put our y with our y, and do we know how we're supposed to end it? How are we supposed to end it? Slope. In honor of the... Then we distribute. And then we add 3 to both sides. So we're going to do 3/2 plus 3. We got to have a common denominator because 3/2 plus 3 1s doesn't make sense. So we're going to do 3/2 plus how many halves? So 3 1s is how many halves? It's 6/2. So we get 9/2. Barbecue work. Hey, you guys have your homework. It's stapled there, right? Do it. Peace.